The next section is allocation of NPP. And this is slightly awkward phrasing because plants aren't allocating NPP. They allocate resources to growth, and that growth happens in different places. But still, we're going to take a look at some of the patterns of NPP for different parts of plants. Patterns of biomass allocation minimize resource limitation and maximize resource capture in NPP. So, plants essentially have a decision to make. They can allocate biomass to stem, to leaves, or to roots. And for a given marginal unit of resource, they can apply that to producing more roots, more stems, or more leaves. And the relative benefits of producing more roots, stems, or leaves depends on the situation and isn't quite so straightforward. Plants respond to changes in limitation by increasing allocation to acquisition of limiting resources. So essentially, the theory is that if there's a resource limitation below ground, so nitrogen is in relatively short supply or there's a lot of competition for that nitrogen, then a given plant with a distribution of biomass in leaves, stems, and roots might benefit from producing more roots because they already have an excess of carbohydrate and they need more nutrients to be more in balance. Alternatively, if they're limited by light, it wouldn't necessarily make sense to have a large root system if there was a large nutrient supply. Instead, it might be better to produce more leaves to be in balance such that light and nutrients are supplied in a ratio that's equal to their demands. There's three different ways that plants can respond to changes in limitation or to differences in limitation across sites. The first one is to increase the acquisition of a resource by producing more biomass of the appropriate tissue. So if you have a plant and it's got a stem, a leaf, and a root, and water and nutrients are limiting, it makes sense to then produce more roots below ground. So if you have to increase your acquisition of nutrients, produce more biomass below ground to get that limiting resource. Secondly, it could also increase the activity of each unit. We've already talked about upregulation and downregulation a little bit, and the plants have some capacity, if it has a leaf, a stem, and a root, to increase the activity of those leaves and photosynthesize at a faster rate. Or below ground, upregulate the activity of roots and take in even more nutrients per unit root. Lastly, plants can also retain biomass for a longer time. So, if you have a leaf, a stem, and a root, these leaves, stems, and roots turn over to a certain degree. They don't live forever, and it's under some control. Plants definitely senesce off leaves, and whether they senesce roots or not is uncertain, but there's factors that they can do to maintain roots for a longer period of time. So if light is limiting, in some cases, it might be beneficial to retain leaves for a longer period of time and increase the amount of light that they can acquire. And it's a lot easier to maintain the biomass you have sometimes than to produce more biomass. NPP in most ecosystems is limited most strongly by a single resource, but also responds to other resources. Now I'm going to try and put together another section on theories of limitation and how we consider limitation. But I'll touch on it briefly here. NPP in most ecosystems is limited most strongly by a single resource, but also responds to other resources. And the ideas of limitation are relatively complex. So the simplest way to think about it is that most ecosystems might just be limited by one resource, but we can add other resources that might increase the availability of the first resource. The way limitation works in the proximal and distal limitation for plants is a complicated topic, but it's good to know that in many ecosystems, NPP responds most strongly to a single resource, but also to others. So there's no one limiting resource necessarily in a given ecosystem. And plants adjust resource acquisition to maximize capture and minimize limitation by the most limiting resource. So again, if you compare sites and you look at the ratio of allocation of resources to leaves, stems, and roots, if you look at the differences among ecosystems, in leaves, stems, and roots, there seems to be what we think of as some correlation between how much biomass is allocated below ground versus above ground, and whether you're limited by nutrients or by light. So grasslands, for example, are thought of as having a large root system, and forests as having a large shoot system with lots of stem and lots of leaf. These forests might be limited by light, and the grasslands more so by nitrogen. Now, there's a lot of factors that contribute to the overall ratios of biomass that are there, one of those being differences in turnover time. But as a generalization, it's okay to think, at least for now, that the most limiting resource is associated with the greatest amount of acquisition to maximize the capture of those resources. Storage also plays a role in understanding the patterns of limitation. Plants have stores, so for the plants that are there, when they take up resources like nitrogen, some of that actually gets stored in leaves and can be reallocated at a different time to the production of new leaves, for example. And so limitation changes over the course of the season, and these stores of nitrogen, for example, or carbohydrates also change. And so the patterns of limitation are buffered by storage. And storage of amino acids, inorganic nitrogen, carbohydrates are important ways that plants equal out variations in resource availability. Now, we tend to think of resources as being relatively external to the plant, and little that plants can do to increase the supplies of resources. If that was the case, limitation would be pretty simple. You simply measure the supplies of different resources, like light or water or nutrients, compare the ratios of those supplies, and then determine the relative limitation by those resources. What makes things complex is that plants can increase the supplies of limiting resources. So not only can they allocate more biomass, for example, to the area where they acquire limiting resources, but there's things that they can do that increases the supplies, which is a way to almost increase the activity of the biomass that's there. Two real simple examples that are somewhat obvious. The first is nitrogen fixation. Legumes below ground have ways to fix atmospheric nitrogen through symbioses that occur in the nodules that they produce. And so you can measure the nitrogen supply of a soil and get a number for that, but it also depends on what species you have, because some species can actually increase the supply of nitrogen. There are other ways to increase the supply of nitrogen, for example by using mycorrhizal fungi. Erication plants in the Erica genus, have ericoid mycorrhizal fungi, and these have the ability to secrete proteases. And what that does is that actually increases your supply of nitrogen back to the plant. And so if you don't have these mycorrhizal fungi and they're not secreting their proteases, the amount of nitrogen that gets supplied to plants is pretty low. Put these plants in places where there's a lot of organic N and soil organic matter, and they can start to break that soil organic matter down, and the released N is taken up by the plant. So knowing what the supply is of resources depends on what species there and how they manipulate those resource supplies. That makes understanding limitation complicated, because limitation then becomes a function of what species are present at a site.